we will be looking at arithmetic series and the sigma notation. This is our sigma symbol there. In this video, so far in this unit, we've looked at arithmetic and geometric sequences. Now we're moving to series. So the definition: the sum of the terms of a sequence is called series. So we take all the terms from a given sequence, we add them up, and that gives us a series. For an arithmetic series, the sequence must be finite. So it says the finite arithmetic series, so term a sub 1 plus a sub 2 plus a sub 3, etc., can be written in summation sigma notation as follows. Normally you'll see the n above and the j equals 1 below, and this is the way that we can use that sigma value there. I think just the way they formatted the text here, it's got it side by side, but technically it should be above and below. Example 1, express in sigma notation the sum of the first 8 terms of the arithmetic series given by this rule. So we're just expressing it using the sigma notation here. So the first thing we're going to do is simplify this rule a little bit. So they give us this, so we'll distribute the 3n, and we'll get a sub n equals 4 plus 3n minus 3. Simplify that, a sub n is 3n plus 1 if we simplify that part right there. So here's our rule. Now using the sigma notation, so we want to start with the first term, n equals 1. We're using n here, that's our variable, and we want to go to the 8th term that in the sequence that we're going to sum. So this is the way that starts, and then we write our rule, 3n plus 1, and there it is. That is the sigma notation for the given rule for the first 8 terms. So we're summing up term 1 through 8. And we probably should put this in parentheses there, and we'll call that good for example 1. Okay, example 2, expand this finite series. So they give us our sigma notation here, so they are asking us to use 2 as the first input all the way up through 6, increasing 1 at a time. That's basically the way that they are asking us to set this up. So I'm going to rewrite it using putting the values where they should go, above and below, not beside it like they have it formatted there. And our rule is parentheses k squared plus 1. So the first term, that would be 2 squared plus 1, plus the next one would be 3 squared plus 1, plus 4 squared plus 1, plus 5 squared plus 1, plus 6 squared plus 1. And then we stop there because we've gone from 2 here all the way up to 6 here. And those numbers are listed there. That's what this means to do. So this is expanded. They didn't ask us to sum it up. They just asked us to expand it. We can simplify. So 2 squared plus 1 would be 5, plus 3 squared plus 1 would be 10, plus 4 squared plus 1 would be 17, plus 5 squared plus 1 would be 26, plus 6 squared plus 1 would be 37. So we can simplify it a little bit like this. But that would be the finite series expanded based on what they asked us to do there. Okay, example 3, expand this infinite series starting with an index value of -1 going to infinity. Alright, so let's rewrite this with the everything written where it should be, and our rule is -1 raised to the power of I times I over 5. So we're going to start with -1, plugging that in for the I value here and here. And that would be -1 raised to the -1 power times -1 over 5. And close that parentheses, put that in brackets there. And then we're going to add, and that would be -1 to the, after -1 comes 0, and that would be 0 over 5, and then plus next would be -1 to the first power, and 1 over 5 here. So we're just replacing everywhere there was an I, we're adding putting our integers in there, and then we're out of room, so I'll come down here, plus -1 to the second power times times the quantity 2/5 plus, and you just keep going here, -1 to the after 2 comes 3, and that would be times the quantity 3/5, and so forth and so on, and it continues on forever. So we can simplify this. So -1 to the -1 power would be basically 1 over -1, which is just -1, times -1/5 gives us +1/5. So that's how that would simplify this one right here. And then -1 to the 0 power is 1 times 0 over 5 is 0, 1 times 0 is 0, plus -1 to the first power is just -1 times 1/5 is -1/5, plus a -1/5, and then plus -1 squared is +1 times 2/5 is 2/5, plus -1 cubed is still -1 times 3/5 would be -3/5. So I could come in here and change this to a subtraction symbol, simplify it a little bit, and change this one to a subtraction symbol, and then that sequence would continue. If we were, the series I should say, would continue beyond that. Obviously we're not going to keep going any farther. Technically we're supposed to go to infinity there. Okay, example 4. Without actually finding the sum, use sigma notation to express the sum of this arithmetic series. Alright, so they tell us it's arithmetic, and we can see that the common difference value is 4, or it's increasing by 4 each time. So the common difference is 4. The a sub 1 value is equal to 6. And we need to find what term is that one right there. So we need to use go back to the previous lessons and use our formula to find an arithmetic sequence. So that would be a sub n equals a sub 1 plus the quantity n minus 1 times the common difference. And plug in what we know. We want to find what term number, so the n value of that term right there, we need that so we know how to fill in our sigma notation. So 46 equals a sub 1 is 6 plus n minus 1, that's what we're solving for, is that n there, times our common difference of 4. So we get 46 equals 6 plus 4n minus 4. So 46 equals 4n plus 2. Subtract 2 here, solving for n. 44 equals 4n, divide by 4. So n equals 11. So this is the 11th term. So using our sigma notation, we put our sigma symbol in. We're starting with the first term. We'll just use an n value. Here's our variable. So we're going from n equals 1 to 11. And our rule, let's simplify our rule here. We had it right there as 4n plus 2. Put that in parentheses. And that answers example 4. So we had to find the rule. We had to find the highest term that we were working up to, in this case the 11th term, and we know that we were starting with the first one. So this is the sigma notation that answers example 4. Alright, example 5. They give us this new formula here. Sum of a finite arithmetic series, sum of the first n terms, is given by s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n, where that's the first term, that's the last term that you're wanting to find, and then n would be the total number of terms that you're working with. Alright, so find the sum of the first 30 terms. So we're going to use n equals 30 here. A sub 1 is given as 2, and our a sub n value, the last term, is going to be the 30th term. We don't know what that is yet, so we have to find what is the value of the 30th term. So we're going to use this formula, a sub n equals a sub 1 plus n minus 1 times our common difference. So for us, a sub 30 is what we want to find, is equal to a sub 1, 2, plus the quantity 30 minus 1, because we're finding the 30th term here, times the common difference. The common difference is 3. It's going up by 3 at a time. So that equals 2 plus 90 minus 3. So that 30 there. So equals, let's see, 90 minus 3, 87 plus 2, 89. There we go. 89 is the last term. So now we plug it into this formula. So we get n over 2 would be 30 over 2 times a sub 1, 2, plus a sub n, 89. So then we get 30 over 2 is 15 times 2 plus 89 is 91. And if you do 91 times 15, you'll get 1,365. So the sum of the first 30 terms of this specific arithmetic series is equal to 1,365. All right, that's it for example 5, and that's it for this video.